Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So today we're going to talk about the geometry treasure 2, which is a problem to measure the height of an island mountain. Okay, so the problem is like this. We have an island here. And the island has a mountain, right? And we want to know the height of the mountain. And we are on a boat. We're on a boat. And we don't know the distance from the, right, this is water, this is a sea. We don't know the distance from the boat to the island or to the mountain. Okay, we don't know the distance. We want to find a way to calculate for the distance from the boat to the this center of the mountain, and we want to find the height of the mountain. So what we can do is that we find a ruler here, right? We find a ruler here, and that's a ruler. When we can just put it here, and then we just step back to a point that when we see through this the tip of the ruler, we can see through the tip of the ruler and the highest point of the mountain. These 3 points are on the same line, right? So we can do this first. So we know the height of ruler and we know how much we step back. For example, this is a problem from an old book. So at that time, people use a step as a measurement. So let's call this one as 123 step. Okay? And then we step back for, let's say, 1,000 steps. Right? So we step back from here. No, actually from here. From the position that we put the ruler, we step back 1,000 steps, and then for here we have another ruler, and we do the same thing. But this time we need to step back further, when we can see through the tip of the ruler to the top of the mountain. Right, and the distance of this is 127 steps. So the distance from here to here is 1,000. Right, and the height of the ruler is 5 steps. Now the question is, can you find a way to calculate the distance from this edge to the center of the mountain and find the height of the mountain? So let's just mark it. Let's see, this is P, this is Q, this point is K, this is E, and this point is H. This one, let's call it A, G, C, for example. Okay, I think I demonstrated this question clearly. So the question is that we know that CG equals to 127. We know that GK equals to 1,000. We know that HK equals to 123. And we know that AG equals to EK equals to 5. And the question is, what is KQ and what is PQ? Right? So for the Asian people, it's a very difficult problem because in the Asian China, we only use the characteristics to represent for the mass, which is extremely difficult. But for modern people, it shouldn't be that difficult because we can see easily that the triangle HEK is similar to triangle HPQ, right? And also triangle CAG is similar to triangle CPQ. Right? Based on this, we can have the following equation, which is EK to PQ equals to HK to HQ, which is HK plus KQ. Right? And also AG to PQ equals to CG to CQ, which is CG plus GK plus KQ. Right. So we just put the number in it. What is EK? EK is 5. And what is PQ? PQ is a variable we're looking for, right? And what is HK? HK is 123. So 123 plus KQ. KQ is a variable we're looking for. And what is AG? That's 5 to PQ equals 2. What is CG? 127 to CG plus GK. GK is 1,000. So okay. Now it's very obvious, right? It's very easy to solve it because 5 times 123 plus 5 KQ equals to 123 PQ. And 5 times 1127 plus 5 KQ equals to 127 PQ, which means 4 PQ equals to 5 times 1127 minus 123. Right? That equals to 5 times 1004. Right? That means PQ equals to 5 times 1004 divided by 4, which is 5 times 251. So that is 1255. Right? That's a PQ. And we can calculate for the KQ. KQ equals to 123 times PQ, 1255 minus 5 times 123, right? And then divided by 5, which is 123 times 251 minus 123. So it equals to 123 times 250. Right? That's KQ. That's a PQ. Okay, this problem seems very easy here. But remember, this is a problem solved by Chinese characters, and also this problem was solved like 2,000 years ago. So at that time, it's kind of difficult. And another version of this problem is way more difficult. Remember here, we want to find the height and distance of the mountain, right? We basically did 2 measurements, right? We did the first measurement and then we step back for 1,000 steps and then do the second measurement. So for another problem, we need to do 4 measurements, which is a problem like this. So assume that we're on the cliff. Okay, we're on a cliff. We're on cliff here. And we're looking at the other side. We know there are some, it's like a lake, okay, a very clear lake in between. So, because it's so clear, we can see through, right? We can find the point at the surface of the lake. And we can see the bottom of the, we can see through the bottom of the lake. Here, we don't consider about the refraction of the light. Okay, we just think about we can see through directly. There's no reflection. There's no refraction. So don't think about it physically. Okay, it's just a problem. Let's assume that we can see through it. Okay. Now the question is that is there any method we can, because we don't know, we're on the cliff. We don't know the distance from the cliff to the lake, right? We don't know this distance. So the question is there any method that we can figure out how deep the lake is? The answer is yes, there is. So assume that we have a ruler here. Okay, we have a ruler here, which has a 90 degree. It's a right angle ruler. Okay, we have a ruler here. And the first thing we can do is that we see through from the top of the ruler. Of course, this ruler is ourselves, so we know the distance of this, right? So let's call this point as A, this point as B. We know the distance of AB. AB is, we know the distance of AB. And we can see through from point A all the way down to, let's call it, all the way down to the bottom of the lake, right? So then we can capture the distance BC here, right? By the way, we don't know the distance of this, right? We don't know the distance from the cliff to the other end of the shore. So, and we can see through from point A to the surface of the lake. And write down, we know BC, we know BD, right? And we do it again here. So because this ruler has a fixed sizing, so we know that EF equals to AB. And because we move it up, so we know the distance of AF, right? So we know the AF, we know EF. And we do it again. So we know GF. And we do it again for the surface of the lake. We know the distance of FH. Right? Now the question is, can we calculate for unknown is MN. We want to calculate for MN, and we want to know how far we're from the lake. Okay, so that's a problem. Actually, this is not only the problem, this is part of the solution, right? Because we move it up, so we have more measurement. Basically, the real problem is that we're standing here and we're wondering how high we are above of the lake and how deep of the lake is, right? That's a question. And actually, how far the from the other end of the shore to this cliff? That's a question. And the solution is that we can just do two measurement, right? We can do two measurement to solve that. And the question for the audience or for the readers of the book would be, is that based on this solution already being provided, can you find the calculation method, right, to get the distance of mn, distance of bk? Okay, so here we do this. We capture the AB. We know that triangle AB, let's just do this. Okay, so the distance of MK equals to the distance of let's call it BP, okay, BP. So we know that the triangle ABC is similar to triangle NPC, right? Which means we can find AB to PN, which is MN plus PM, which is MN plus BK, right? So MN plus BK. That is AB to PN equals to BC to PC. Right, it equals to BC to PC. But do we know about the PC? We don't, right? We don't know the distance of PC, we only know the distance of BP. So we can do this. From this one, we can do AB to MN plus BK plus AB equals to BC to PC plus BC, right? That means AB to MN plus BK plus AB, which is AK. MN plus AK equals to BC to BP. Right, we get the distance, we get BC to BP. That's for the first observation from A to N. And for the second observation, we know that triangle ABD is similar to triangle MPD, right? MPD. This triangle is similar to triangle MPD, right? This triangle. So we know that AB to MP, which is BK, equals to BD to PD, right? From here, we can get AB to AB plus BK equals to BD to BD plus PD, which means AB to AB plus BK, that's AK, equals to BD to BD plus BD plus PD, that is MK or BP, right? Therefore, for the first measurement, we have the following equations, which is AB to MN plus AK equals to BC to BP, and AB to AK equals to BD to BP. right? Remember that the AK is unknown here, MN is unknown here, BP is unknown here, right? But let's just reform this equation. Then we get AB BP equals to BC MN plus AK equals to BD times AK, right? Which means BC MN equals to BD AK minus BC AK, which means it equals to AK times BD minus BC. Okay, so we have BC MN equals to AK times BD minus BC. Let's call it 1. Okay, now we can see in this equation, we don't know MN, we don't know AK, right? For other part, we know BC, we know BD. Right, similarly, we do the second measurement. Remember, this measurement will give the similar result to this one, so we can directly write down the second measurement result, which should be, here is a BC, right? Let me try to show this. Here is a BC. So for the next measurement would be FG, right? That's a known part. FG times MN should equal to, here we have AK. For the next measurement would be EK, right? Times BD minus BC, which is FH minus FG. That's the second one, right? So we don't know the distance of EK, we don't know the distance of MN. It looks like we have 3 variables here, AK, EK, MN, but actually we only have 2 variables here. Because EK equals to AK plus AF plus EF. And AF and EF are the known number. We just call it AE. So EK equals to AE plus AK times FH minus FG. Okay, now we have 2 equations and we have 2 variables, AK and MN. We can easily find it. Okay, I'll just stop here. So that's the method we used before, like in very old time, in the I don't know, maybe 1,000 years ago or 2,000 years ago, in Chinese math book. If the people want to calculate for the distance of the lake, right? The distance to the lake and the distance of the other shore to this cliff, and also calculate for the depth of the lake. I think it's a very smart idea, and again, for the modern people, we have these modern mathematic expression that actually simplifies the problem. Right? If you just use the Chinese characters to derive these formulas, that would be extremely difficult, I would say. Even I'm a Chinese, I can't read it. Okay. That's it. I hope you like this video. See you in next one. Thank you.